Hello, good afternoon. It's time for the class already, so I believe we can join. All right. Okay. Good afternoon, everyone. Uh, I believe we all had a great weekend, and gradually we are in the week 3 of our Operation Agriculture Incubation Program. So we just entered the third week of the program now, and the program still continues. Like we have various courses and various insightful sections from different experts from their field. And today we are going to be talking about drone technology. I'm sure we've all heard about drones, or majorly 90% of us have heard about drones because uh, people use them in the media industry, photography, videography, and all. But I think we just have a brief information about it. So we have an expert who's going to be talking in details, taking us through so many things that will really amaze us about drone technology. But before I bring him to the stage, I quickly want to share with us certain information. Okay, so as we all know, this is Precision Agriculture Incubation Program Cohort 2, and the concept behind this program. So, Precision Agriculture Incubation Program is a digital agriculture capacity building program from staple of Precision Field Academy, the classic African digital agriculture training school, bringing about transformation in the agriculture sector through comprehensive and expositive training for youths on the concept of precision agriculture technologies and its application to solve today's pressing challenges emanating from the agriculture landscape to strengthening and stabilize economic prosperity. So, recognizing the transformative potential of precision agriculture, there is an urgent need to equip young emerging farmers, agriculture professionals, and aspiring agripreneurs who falls into the demography of youths with the need for requisite knowledge and skill to harness the technologies effectively for global opportunity and exploits. So the Precision Agriculture Incubation Program addresses the need by providing comprehensive training in the key areas such as drone technology, GIS, data science, robotics, Internet of Things, artificial intelligence, machine learning, business and drone business and entrepreneurship. So through this program, participants are empowered to embrace the necessary to embrace innovation, optimize the farm management practices, and contribute to the overall advancement of the agriculture sector by creating local content digital solutions. So let me quickly move to the uh, okay. So the 7 objective about this program. Number one is to close the knowledge gap. Uh, number one is to close the knowledge and skill gap of participants about precision agriculture technologies and practices. And number two is to raise the next generation agriculture remote pilots. Number three is to groom young precision agriculture leaders and stakeholders for global exploits. Number five is to build the capacity. Oh, sorry. Number four is to build the capacity of youths in the aspect of technology application in agriculture. Number five is to promote adoption and innovative and sustainable farming technologies that improve agriculture productivity and resources management. Number six now is to foster entrepreneurship and encourage participants to develop technology-driven solutions and agriculture challenges. And lastly, number seven is to create a network of digitally empowered young agricultural professionals who can drive positive change in their community through transformative power of technology. Okay, so this program falls into two track. We have the employability track and the entrepreneurship track. So there are two set of people attending this program. Maybe young farmers who are interested in digital agriculture and been using maybe Earth observation um, technologies like Google Earth, Google Engines, and all of this satellite imagery, and are actually looking into expanding their knowledge on the concept of precision agriculture. And secondly, people who want to be um, employable and also want to possess the requisite skill needed for to actually make them valuable and competitive in their career or industry. And so we have the mode of training. The mode of training is in virtual and in person. So for virtual, we have virtual facilitation sections like this, where we have online trainings from uh, global faculties around the world, and we have the on-site training, which is going to be the practical. That's the field experience where you get to learn about drone technology, have hands-on experience on simulator, drone building, and some other practicals. Okay, so the demography of the people we're actually looking at is 18 to 35 years because we believe these are still young people and we need to build the capacity of young people, not just, old people, people who are actually young and can actually visualize a positive future for the future of work in agriculture. So our focus areas number one, drone technology. So we're going to be looking deeply into drone technology. So tomorrow we will also have another section on drone technology, which is going to be talking about crop protection, uh, basically. So it will be handled by the convener of the program, Mr. Femi Adekoya. So we get the information after the class. So another section of focus area we have here is GIS and remote sensing. Uh, we had a class last week on through Mr. Kuri talking about satellite imageries and how you can collect data for agriculture, do plant classification, crop monitoring with the aid of satellites. And we also have robotics and Internet of Things. So we also had some previous classes talking about IoT devices, their application in livestock farming, in the aspect of cattle and poultry. So we also have another class coming up. This is going to be strictly based on crop monitoring with the use of IoT, moisture sensor, and irrigation control system. That should be happening that next week. Yes. So we also have here enterprise and business development skill. So there will be a section here where we'll talk about enterprise business development, talking about your business structure, customer acquisition, sales and marketing. So it's an holistic curriculum bringing both enterprise skills, technical skills, and soft skills that you actually need to be relevant in the world of Russian agriculture. So, okay, I talked about this. Okay, lastly, I need to touch this before I leave. Uh, Dr. Akim Adeshino, the president of African Development, made mention of a profound statement. He said, unless African uses modern technologies, our farmers' output will remain low and we will remain dependent on others to feed us. So, uh, what this statement means is that we can actually see better, we can understand farming practices better, relying on technologies, digital technologies that can help us to collect accurate data, understand the real-time data of what is happening per time to be able to take the corrective measures that is needed, not just guesswork. So this is about eliminating guesswork by rely on digital technologies to actually stay informed about what you. So in this case, you are if maybe a portion of a farmland, actually what is missing there in that plant is maybe nitrogen or phosphorus. So you don't just keep bringing different things into it. By that you are wasting resources, and you're also choking the plant for not getting the right amount of nutrients or inputs needed. Okay, so let me quickly talk about this. Precision Field Academy is the organizer of the program, as we all know. And at Precision Field Academy, we have a vision to create a world where every young person, regardless of the background, has the opportunity to become a digitally savvy farmer or a agricultural professional, driving sustainable and equitable growth in their community through the transformative power of technology. And our mission is to raise the next gen farmers that are tech inclined and digitally savvy. So about Precision Field Academy. Precision Field Academy is a social enterprise where we train and build the capacity of young professionals in modern and emerging technologies for the future of work and to lead with precision agriculture. So we have core three methodology. Number one is education and knowledge sharing. Number two is training and skill development. Number three is coaching and mentorship. And we have six tech skill in focus. Number one is drone technology. Number two is GIS and remote sensing. And number three is data science for agriculture. Number four is robotics and Internet of Things. Number five is artificial intelligence and machine learning. Number six is enterprise development. All of these skills combine both the technical and enterprise skill to actually make you uh, competitive, valuable in your industry. So why do we do what we do? What's our motivation for doing this? Running Precision Field Academy to build the capacity of youth. We understand that there's a skill gap that needs to be closed, and the young professionals need to build the skills on both technical and enterprise part for the future of work in agriculture. So number two is that observing the trend is not enough. So youth need to be an enabler. Youth need to be directly involved in this technology rather than just being mere observer. So lastly is technology is the key to unlock African agricultural potential. So we can bank on technology to spearhead our productivity and increase efficiency in the agriculture industry. So why should you join us? We are creating the future we want in agriculture, and we also connect you to the world of information and scholarship opportunities, volunteership, internship on both international and local scale. So also we have skill development through project collaboration, community interaction, workshops and symposium. And lastly, we have access to coaching and mentorship from industry leaders and professionals around the world. So at Precision Field Academy, we are building a community of young tech inclined and digitally savvy farmers. So let me quickly bring to the stage our speaker for today. So today we're going to be discussing in details introduction to drone technology, and speaker for today in the house, Mr. David Okateibo, is going to be taking us through this topic. So I think it's in two folds. We have the general information. Is going to be talking about both the general and the technical details about drone technology. So I'm going to quickly through his profile. So, all right, our speaker, David Okateibo, is a drone tech professional dedicated to facilitating remarkable growth and advancement for businesses through the integration of cutting-edge drone technology in their operations. We offer piloting and maintenance services, consultations, procurement, assistance, and customized drone development for diverse industry needs. So with over 300 hours of logged UAV flight time, David brings invaluable experience to the table. His expertise span across telecommunication, construction industry, real estate industry, topographical survey, energy, and oil and gas. So beyond this professional endeavor, David is the founder of Dronarios, an educational brand committed to nurturing the next generation of drone pilots. Through Dronarios, he equipped aspiring pilots with essential skills, knowledge, and a strong emphasis on safety to ensure the delivery of high quality aerial services. Hello, Mr. David, if you can hear me. So you have the floor now. I think you can share your screen.
Hello and good afternoon, Mr. Joseph. Thanks for having me. It's an honor to be here once again.
Okay.
Can you hear me?
Hello, I can't hear you. I don't know if you can hear me.
I can hear
I
you.
can't
Hold
hear
on,
you as
stand by.
well. Okay.
Can you hear me now? Hello, can you hear me now?
Hello.
Hello, can you hear me? Can you
Hello.
can you hear me?
Yes, yes, yes. I can hear you now. I can hear you now.
All right, awesome. Good afternoon, and it's an honor to be here once again.
Okay.
Just give me a moment.
Okay. Okay. All right.
All right, good afternoon, everyone. I believe you can hear me. If you can hear me, kindly type you can hear me in the comment section. Okay. All right. Good afternoon, everyone. My name is David Okwateibo. Joseph has done justice to my introduction, so I'll just move right to it. Today I'll be talking about introductions to drone technology. So we'll be looking at the general consideration and also the technical considerations around drones. To start with, I would like to start with a quote by Bill Gates. And the quote says, drones overall will be more impactful than I think people recognize in positive ways to help society. Right? Now, when Bill Gates said this, it begs the question. Number one is, why should you care about drone technology? What exactly are drones themselves, right? What are drones? Why should you care about drone technology? Why are drones gaining traction in the world that we live in? Primarily, what's the fuss all about, and why should you care as an agriculturist, right? Now, these are all valid questions, and I'm going to get to them. But before we do that, let's lay a foundation. So, the global population, right, is projected to reach 9.7 billion by the year 2050. And this places significant pressure on the demand for food production or increase in food production. Now, according to the FAO, which is the organization for food, the Food and Agriculture Organization, right? The 34% increase in population, for us to be able to meet the need of food, right? We need to have 70% increase in food demand or in food production. And because of this, there's a problem, and that problem is the fact that conventional means of providing food or meeting this demand is insufficient as our population grows. Now, to solve this problem, a new kind of agricultural system comes in, which we call precision agriculture. Now, precision agriculture is a crucial strategy that optimizes the use of resources and that leverages on technology to increase productivity. Now, many of these, there are many components, right, when it comes to precision agriculture. We have stuff like remote sensing, yield monitoring, the use of artificial intelligence, Internet of Things, along the likes. Now, drones are an integral part of this because they offer, number one, real-time data connection and analysis, and enable farmers to make data-driven decisions to improve management practices, crop management practices. Now, according to a report by PwC, the market for agricultural drones is projected to reach $21 billion by the year 2025. And this is driven by increasing, adoption of precision agriculture technologies, for example, increase in the use of drones. So that begs the questions: what exactly are drones? Now, drones are simply aircrafts with human pilots on board. Drones, simply put, are aircrafts without a human pilot on board. So imagine yourself at the airport. You're boarding a flight, but then instead of having your pilots inside the aircraft to fly you, let's say, from Lagos to Abuja or from Nigeria to Dubai, there's no pilot in the cockpit. Instead, your pilot is seated either somewhere at the airport or even in a remote location, either being able to control the aircraft, right, and carry you from place to place without being inside the aircraft itself. Or imagine another scenario where you board an aircraft, there's no pilot, and the aircraft by itself aligns itself with the runway, takes off, flies you to the destination, lands automatically without any human intervention. That's what we're talking about when we're talking about drones. But this time around, don't let us go too far, right? Let's assume that we're not talking about aircraft that are that big or that carry humans. Instead, we're talking about smaller machines that can be used to do quite a number of things. That's what we're talking about when we're talking about drones. I believe that makes sense, and I believe that's clear. Okay, now that we have gotten that out of the way, let us look at the evolution of drone technology, right? So, drones were first developed and used by the military, and that was in the year 1800s, right? Mid 1800s. They're first used by the military, just like many of the technology that we have in the world right now. For example, your GPS, right? They were first used by the military, and then as time went on, they started being adopted for civilian purposes. So as the technology began to advance, started gaining traction in the commercial space, and in the early 2000s, we had an increase in demand for drone-based solutions, which cut across different industries, including agriculture. For example, drones started being used in the agricultural space since the year 2000s, early 2000s, primarily for aerial imaging and also for mapping. We'll get into what all that means as we go along. Now, drones come in different shapes and different sizes. I'm very sure if you have been to an event before, you've probably seen someone who is flying a small machine to take pictures and photos in an event. That's an example of
Mr.
a drone.
David, your
But
slide is not moving.
my slide is not
Your
moving.
slide is not. Yes, 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 yes. It's still in
Wow.
the title page, so
It's in
I
the title
can.
page. Okay. Hold on, let me
Yes,
check.
yes. I can see introduction to the technology. It's in the title page.
That's odd. Stand by. How about now?
It's still not
Is it
moving. It's
moving?
still not moving. No, 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 no,
Okay.
not yet. It's not moving
Give
yet.
me a moment. Give me a moment.
Okay. Yes, yes, it is moving now. It's just changed to the Bill Gates quotes and that's page two.
Is it moving now?
No, it's not moving. It's not moving. It has
Wow.
returned
Okay.
back to the title page, so it's still in the first slide.
How about now? Which slide is it now?
I'm seeing the title page, Introduction to Drone Technology. That's the first slide. It has returned
Oh
back to
my.
you. I think you can
Just stand by. Let
uh,
me close my slide
see
and
that
start all over.
slideshow. Okay. Uh, I would suggest maybe you should just present it as slideshow, so I'm able to scroll. Hello.
Can you hear me?
Yes, 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 yes. Very loud.
Yeah, I said I'm presenting a slideshow, so it's strange that it's not showing that way. I'm presenting a slideshow.
Okay, okay,
Let me know if it changes now.
okay.
Is it changing?
No, it's not changing. It's still in the title page. The first slide.
On my end here now, it's showing this gate page. There's a
It's changing at your
problem.
end.
Yes. Okay, let's try it again. How about now? Can you see my screen?
Yes, I can see your screen. It's not changing yet. Probably it's just share a slideshow. Then you
That's exactly what I am doing. I'm on slideshow from my end. If you look at my screen now, I'm sharing a slideshow.
because I can see your entire screen. Yeah, I can see your entire screen. It's not even showing displaying as a slideshow here.
Okay, just wait. Uh, Hold on a minute. Stop sharing. Present slides. Share screen. Um, just stand by a minute. Share present.
Okay, okay.
Uh, Stop screen. Come on. How about now?
Okay, let me bring it back to stage. Yeah, I think we are good now. So okay, it's changing now. Yes, we are good. We are good. Okay, so you can go
All
ahead.
right. Yeah, just stand by. Okay. Is it changing now? Is it changing? Hello?
Yes, it's changing. It's changing. We are
Okay, all good.
presently in the slide. Okay.
All, all right. Where did I stop? All right. So, sorry for the technical difficulties. So let's go back to categories of drones. So, like I was saying, so we have different categories of drones, right? So, for example, like the one you have in your are being used for events, right? Now, drones come in different shapes and different sizes. Now, while they come in different shapes and different sizes, we can categorize them into four. That is, if you take all the drones on Earth and you decide to group them, right, no matter what they look like, you're going to be able to group them into four. So the very first one that we have are what we call the fixed wing drones, right? Now these fixed wing drones are drones that look like your normal airplanes, and they fly like your normal airplanes, right? That's what your fixed wing drones are. So they have wings, they have fixed wings, like their name implies, just like your birds, and then that's what allows them to fly. The next one we have are what we call rotorcrafts. Rotorcraft are simply drones that are replicas of your helicopters, right? So they look like your helicopters and they fly like your helicopters. So they take off and land just like your helicopter does, and they fly basically like how your helicopter flies. Now we have another category which we call the multirotors. Now multirotors are one of the most common drones that we have in the marketplace, and those are pretty much the ones you see in events. They're called multirotors because they have more than one blade. So you see most of them, you see them with having like 4 rotors and 4 blades, right? Now, each of these categories have advantages and disadvantages, right? For example, your fixed wing drones are able to fly longer and fly farther compared to the rest, that is within the same weight class. But the disadvantage is that you need a runway, like a large amount of space for the aircraft to take off and land, just like your normal airplane. But multirotors and rotorcrafts have an advantage such that they can take off and land vertically. We call them VTOLs, vertical takeoff and landing aircraft. So they can take off and land vertically, which means they require less amount of space. But the thing is, for example, for a rotorcraft, it is highly complex. And for a motor, for example, because they have multiple rotors, the power consumption is more than regular fixed wing, so they consume more power, which means less flight time, right? That brings us to the fourth category, which we refer to as hybrids. Hybrids is simply a merging of the advantages of your fixed wing with the advantages of your multirotor or your rotorcraft. Pretty much, you have a fixed wing that has a multirotor system embedded into it. That allows your fixed wing to take off and land vertically, right? So that you don't need a runway. And then once that's attained a particular height or a safety height, is able to transition to your regular fixed wing, which therefore gives you longer flight time and longer endurance and longer range. I hope that makes sense. Okay, now another advantage of your multirotors, for example, is the fact that they can over in place. So, like your normal airplane now, for example, if your airplane, which is flying, was to shut off the engine and stay on a spot, within a few minutes, the aircraft is going to start descending and start dropping. But your helicopter, for example, and your rotorcraft can stay fixed on a spot in the air for a long period of time, which makes them good for like inspection and precise data collection. Meanwhile, your fixed wing drone has to constantly be moving forward. Okay. Now that brings us to the next thing. So, like I said before, when it comes to drones, there are quite a number of options in the market, right? So, when it comes to drone technology, when it comes to manufacturers, you have a bulk of manufacturers depending on your need. So, your use case or your needs will determine the kind of drone you're going to get in the marketplace. A bulk of manufacturers. So, for example, when it comes to the agricultural industry or the agricultural space, we have quite a number of options available to you, right? Depending on your use cases. The most common one are DJI, Parrot, Precision Hawk, SAG, and SenseFly. We have a lot of others, but these are just examples of companies that are into drones for agriculture. Same thing applies for drones that are used for surveillance and survey, for drones that are used for inspection, for drones that are used for mapping, for drones that are used for delivery and transportation, package delivery. Whatever industry where drone use cases are, we have a lot of manufacturers that are providing solutions, right, for that industry. Now, this brings us to general considerations. Now, one of the critical aspects of using drones in agriculture is navigating regulatory framework. Understanding the rules and regulations governing drone use is crucial for compliance and safety. So there's something, okay, so drones, like I already said, they're actually aircraft, right? And because they are aircraft, we have an industry that deals with aircraft, that is the aviation industry. And the aviation industry is highly regulated. And that's because one of our mantras is the fact that we always put safety first. For example, we are talking about a machine that actually flies, right? Most of them are pretty much heavy. So you can have a drone, for example, that weighs over 25 kg. So imagine that drone falling off from the sky because the person who is operating does not understand the regulations or things he needs to do to fly safely. That drone falling to the ground can serve as a projectile, can cause injury, can cause death, can cause damage to properties, right? So it's always important for you to understand the regulatory framework. These regulations are put in place so that people can safely operate the drones without causing injury to themselves or injury to other people and properties and damages to properties around. So let's look at some of these regulatory frameworks. Now, for example, when it comes to drone safety, we have what we call general regulations and general laws that applies based on the country that you are in. For example, while we have special regulations, general regulations includes not flying above 400 feet, right? Not flying close to buildings, at least being at least 150 meters away from buildings, not flying further than 500 meters away from yourself so that you can be able to see the drone, right? Flying, that is flying within visual line of sight. Not flying close to the airports where we have other aircraft, right? Because there's a possibility that your drone can affect or can, impact the aircraft, maybe damage the engine because you flew towards an aircraft that's currently flying or operating, you know. Um, and many more, right? So there are quite a number of laws and regulations that apply to the use of drones or flying of drones. Now, regulations vary from country to country, regions to regions, right? So while we have generic rules that apply to the operation of drones worldwide, right? There are some peculiarities based on the country you're operating. For example, in the US, the aviation body in charge of regulating drone operations or flight operations is called the FAA, which is the Federal Aviation Administration. In Nigeria, where I'm from, it's called the Nigerian Civil Aviation Authority. Other countries also have their own. For example, in South Africa, we have the South African Civil Aviation Authority. In the UK, we have the UK Civil Aviation Authority. In European countries, we have what we call the European Aviation Safety Agency, right? So all these organizations have their own regulations for drone operations. In Nigeria, for example, all regulations that relate to drones are under what we call the Part 21 rules. For US, it's called Part 107. So depending on your country, right, there are regulations that apply to the use of drones. Whether or not you are using the drones for agriculture or for other use, those regulations pretty much apply. Now, one other thing that comes into consideration when it comes to the use of drones is what we call privacy concerns, right? Now, many of your drones are retrofitted with cameras. For most of the use cases of our drones, they're usually retrofitted with cameras. Because they're retrofitted with cameras, people generally have the fear, right, that they're being spied on when they see a drone like operating close to them or around them. And that's why there are like special rules or principles that you need to apply so as to safeguard the privacy rights of other individuals. Now, there are a lot more as regards privacy issues, but I don't want to bore you with the technicality of that. So we just go on. But generally, drone operators are required to obtain consent, right, and ensure data security and confidentiality. So, for example, if you're to carry out an operation, you have to carry out that operation in a place where you have a lot of people. It's important for you to get consent, for example, from the property owner. So you get a permission that says, okay, I need to operate in this particular area. I will be flying close to your building or over your building. I'd like you to know that I'm not going to take pictures of you. This is what exactly I want to do, right? And then you get consent. And then the owner of the house can say, okay, yes, this is also no problem at all. Or you can say, okay, once I'm done taking all the pictures, I can show them to you so that you see that your pictures are not there. All those kind of things, so as to avoid pretty much legal consequences. Now that brings us to the next thing, which is technical considerations when it comes to drones. Like we already said from the beginning, right? Drones are being used for a lot of things, and we have different categories of drones, different types of drones, and different use cases. So let's dive into the technical aspect of drone technology. Now, when it comes to drones, drones are also known as UAVs. By UAV, we mean unmanned aerial vehicles. So, for example, when we talk about your aircraft in the airport, we're talking about manned aerial vehicles. By manned aerial vehicles, we mean that the pilot, the person who is controlling the aircraft, is inside the aircraft, so the aircraft is manned. But if the person is not inside the aircraft is regarded as an unmanned aircraft. Now, this unmanned aircraft, that is the drone, is actually a subset of an entire system. So the system consists of the drone itself and also the navigation system, the communication system, among other things. Now, drones can be divided into the drone itself, for example, the drone itself can also be divided into several parts, right? So you have your drone, which is the airframe, you have your propulsion system, which actually helps the drone to move, right? You have your power system, that is your battery, you have your communication system, you have your navigation system, like the GPS that is embedded into the aircraft, among many other things. So the drone itself is just a sub part of a major framework. So your major framework now includes the drone, the control system, that is your like your GCS, your ground control station, data link, which is the communication system between your drone and your GCS. But then the drone itself also can also be divided into subsections, like the body, the flight controller that allows the drone to carry out the operation, the payload, which is what the drone used to carry out to do work, right? You have your power system, which is what powers the drone, among many other things. Now let's go to payloads. The most critical aspect of your drone, right, is your payload. Your drone is simply a platform that allows you to do work. Now, the work you do depends entirely on the payload that the drone carries. Payloads are additional equipment that can be attached to the drone to perform specific tasks. These tasks include dropping objects, spraying chemicals, or utilizing various sensors for data collection. So if your drone is carrying a camera, for example, you know that okay, you can use your drone to take pictures and take videos. If your drone is carrying a tank, you know that okay, you're using that drone for spraying. If your drone is carrying a package delivery mechanism or a drop mechanism, you know that you're using that drone for package delivery. Are you getting it? So the kind of work you want to do with the drone will determine the payload that is attached to that drone for carrying out that activity. Now, what's what we call drone sensors. So when it comes to drone sensors, we're talking about your cameras or other type of sensors. So for example, we have gas detecting sensors. We have your thermal imaging sensors, among others. We'll get into that as we go. Okay, so now let's talk about sensors, like I said. So sensors are simply cameras, and like their name implies, sensors are simply gadgets that are used to sense something in the environment. Now, most of the sensors that we have are actually optical sensors, that is, they are camera sensors, but they come in different types. So, for example, we have what we call the RGB sensors, we have multispectral sensors, we have LiDAR sensors, we have thermal sensors, we have hyperspectral sensors, among the likes. Now, RGB sensors are simply sensors or cameras. Let's use the word cameras to make it easy. Are cameras that are able to capture objects just like your eyes is going to capture it. So if you take the camera on your phone, for example, the sensor, which is the camera sensor, is actually an RGB sensor, right? They are used to visually inspect crops, identify issues like pests and diseases. Now, when it comes to light spectrum, when it comes to the world as we see it, right, there's a limit to what our eyes can see in itself. For example, what you can see with your eyes are pretty much like colors, right? Red, green, blue. That's why we have RGB. But there are other types of lights that we have here that our eyes cannot see, like your infrared, right? Like microwaves, like radio waves, right? So we have specialized sensors that allows you to see that. Now, an example of such sensor is called a multispectral sensors. So multispectral sensors allows you to capture images across various bands of light. It can allow you to capture images that has to do with your RGB, just like your eyes can see, but then also adds other images that your eyes cannot see. For example, near infrared, right? Your eyes cannot see infrared lights, but this sensor allows you to capture that infrared light. And with that ability to do that, you can detect plant health, you can detect stress, you can optimize for irrigation and fertilization by calculating vegetation indexes. Now, what's what we call hyperspectral sensors. So hyperspectral sensors also capture other kind of light bands that are separate from what your eyes can see, other color bands. And then because of the more detail or because of the narrow spectral bands that it can capture, it allows you to get more information about like your plant biochemical properties, aiding in early detection of diseases of your crop, nutrient deficiency, environment stressors, and many others. And then you have thermal sensors Like the name implies, thermal. Thermal sensor simply allows you to detect heat emitted by your object, just like your thermometer, right? So thermal sensors. So they are used to monitor crop temperature, identify water stress, and manage irrigation. So they also help detect anomalies in your livestock, assess environmental conditions in greenhouses. They also have what we call LiDAR sensors, light detection and ranging sensors. So simply put, LiDAR sensors uses laser pulses to create 3D images of terrain and vegetation. So what the sensor simply does is the sensor sends light to your crops or to the ground or whatever it is you are capturing. And then once the light bounces back, it uses the data of the time the light takes to bounce back among other data, combines them together to create a 3D map of the terrain and the vegetation. And then we use that for mapping of our fields, for contour mapping, for terrain modeling. So this helps in like land management practices, including irrigation, while also aiding autonomous navigation. So like I said before, each of these sensors provides different kind of data, right, that help farmers to make informed decisions to improve their crop yield, the efficiency, and sustainability. We also have advanced systems like what we call the RTK GPS that helps you to increase the precision of the data that you are capturing from these your sensors or from your drones. Drone components such as motors, your batteries, and sensors have undergone significant advancements as as the years goes by, and it has also helped to improve performance, reliability, and functionality. We have a lot more improvements coming in. For example, the drones that we were operating many years ago, for example, in the early 2016s, many of them didn't have GPS, they didn't have the cameras, didn't have zoom capabilities. They went like thermal cameras then. But as the technology begins to advance, begin to see more use cases, more sensors that help farmers to increase their efficiency and get better. Now, when it comes to using drones in agriculture, right, there's a systemic approach that is necessary. Now, I'm going to talk about the data analysis part where we use drones for managing or looking at crop health and analyzing crop health. So now there's a system, there's a strategic system. Now, this includes mission planning. After you plan your mission, the next thing is your flight execution. Once you've executed your flight, you look at data processing, and then we look at data-driven decision making. Right. So when it comes to mission planning is what you do before you carry out your flight. Right. You don't just go out into the field, take your drone up, and then start capturing data. No, you need to know, okay, what kind of data do you want to capture? What's your area of interest? What altitude will you be flying, and why will you be flying at that altitude? Right. What flight paths are you going to follow to capture the data so as to ensure comprehensive coverage? So you already have a plan. Your mission planning is the time when you plan out everything you want to do, why you want to do it, how you want to go about it. Now, we have different softwares that allows drone pilots with their mission planning phase. Example of such softwares, we have what we call Drone Deploy, we have Pix4D Fields, and many more. Now, once you've planned your mission and everything you want to do, the next thing now is your flight execution, right? Which is when you actually carry out the flight. So this time around, you have gone to you've determined what you need to fly. You've determined this is the drone you need. These are the number of batteries you need. Okay, you need to carry your charger. Okay, you need an SD card. Oh, you need a sprayer. Okay, you need 50 gallons of liquid or fertilizers. You need all this. And then take all that along with you to the field. Now, in the flight execution phase is when you now carry out that mission. That is, you execute the planned mission with precision while you are adhering to safety protocols. Remember, we have regulations that are guiding you for safety, and then you based on that, you carry out your flight plan. Now, while you are flying, of course, you are monitoring your weather conditions. You adjust flight parameters while you're on the ground before you take off, and then once you are done, you come back and land. Now, there are a lot of software that allows you to carry out your flight mission. Many of them actually comes with the drone itself. So, like the applications that come with the drone that allows you to control the drone. This is what you can use for flying the drone. And I also have like third-party softwares that you can connect with your drone that allows you to carry out missions autonomously. So we have, for example, if you're flying a DJI drone now, that will call a DJI pilot app. If you're flying a Anafi drone, you have an Anafi application. If you're flying a SenseFly drone, you have a SenseFly EB application. And then you also have other type of softwares like Mission Planner, Drone Deployer, so that you can use for flight execution. Then the next thing now is your data processing and analysis phase. So you've gone to the field, you wanted to understand the health of your crops, right? So you've captured data, which is multiple images. And the next thing is you want to generate a map that you can then analyze, right? So you come to your data processing. After the flights now, remove your SD card from your drone, put it into your system or your laptop, for example, and then you extract all the data that you have captured into your system. The next thing what you do now is you open your data processing application that allows you to stitch all the images you have captured into one, for example, right, to form maybe like a 2D map or 3D map that you use for analysis. Example of these softwares includes IDSoft Metashape, Microsense Atlas. Some of the companies that allow you to plan your flight also allows you to process your flights, like Drone Deploy and Pix4D. And then once you have stitched all those images together, you can then use the integrated systems in them, like for your data analysis, right? So, for example, there will be like um, options or systems that allow you to now carry out analysis using vegetation indexes like NDVI, and then you can use that to know that okay, this particular part of my crop is not getting enough water, or this particular part is experiencing this type of disease, yield disease, and other kind of things. So we have those who are specialized in data processing and data analysis, but you can also learn that. And then once you have processed your data, based on the result of your analysis, you can then make actionable decisions and say, okay, this process data that I've analyzed, okay, my crop health, this is what I need to do. As far as irrigation, this is what I need to do. As far as fertilization or pest management, these are the things I need to do, right? And then, of course, the data you have processed or analyzed can be generated into like maps, reports, and then you can send that maybe to clients, or you can use that within your team for decision making. So digital software serves as the backbone of drone-enabled agriculture. They facilitate the conversion of raw images or raw data into actionable intelligence. And some of these software options are free. Some of them offer one-time subscription, some offer monthly subscription, and some offer yearly subscription. So it's important for you to consider your use case, your budget, before committing to a specific software. So like I said, there are a lot of services out there, a lot of drone softwares out there. Just like we have multiple drones that you can use, we have multiple softwares that you can use. So based on your use case, what you want to use the drone for, that will determine the drone you're going to get, that will determine the kind of software you're going to get. And then, of course, by the time you are looking at the options that are available to you, they help you to decide, okay, this is the software I'm going to go for because this is my budget. This is the drone I'm going to go for because it's going to do the work I want to do. There's no really right or wrong answer. It's just about what works for you. What works for Mr. A may not necessarily work for Mr. B, even if they're doing the same kind of thing. For example, monitoring crop, because the person who's operating a large scale farm, what he needs is somewhat different from the person who's operating a small scale farm, right? And then that will help decide and help you make your decision. So that brings us to the next thing, flight principles. So we're talking about drones. The question is, how do these drones fly, right? So now that I've explored the different types of drones, their evolution, different considerations to make before incorporating drones into your cycle, let's look at the fundamental principles of flight. Now, at the heart of every successful drone flight are four forces. At the heart of every drone flight that you see, every aircraft flight, your airplanes that are flying in the airport, your helicopters, your balloons, even your drones, there are four fundamental forces that affect them, right? Now, these forces are your dreams, your money, FAA, and reality. No, I'm kidding. All right, so we have four forces, and these forces are lift, weight, thrust, and drag. I come again: lift, weight, thrust, and drag. These forces govern how your drone moves through the air and maintain stability during flight. And they are sub-part of what we call aerodynamic principles. Now, aerodynamics is simply the study of how objects react with air or how air reacts with an object. how objects and air pretty much react relatively to one another. So you basically have an object. It could be your drone, it could be your hand, it could be your phone, whatever it is that you have. The way it reacts to air, pretty much when they move relative to one another, is what we call aerodynamics. I don't know if some of you are daring. Maybe you have been on a bike before, and then or in a vehicle, and then you put your hand outside, and you see that as the car is speeding towards the front, your hand begins to move backwards. The study of what is happening is what we call aerodynamics, simply put. Now, like I said, we have what we call lift, weight, thrust, and drag. So let's talk about lift. Lift is simply an upward force that pushes the aircraft above the air, right? So what makes this drone, for example, to move from the ground up, is what we refer to as lift. For drones, like the one I have with me here, this lift is generated through the propellers. Now, for your airplanes, the lift is generated through the wings, which is the fixed wings of the aircraft. And for your helicopters, it is generated through the rotor blades, that big blade that rotates above the aircraft. Now, lift is created through a combination of forces. We have what we call, or through a combination of principles. Now, we have what we call Newton's third law of motion, and then we have what we call Bernoulli's principle. Those are the two principles that we can use to explain how lift is generated. So let's first start with Newton's third law of motion. How many of you are science students here? Can anybody tell me what Newton's third law of motion says? You can write it in the comment section. What is Newton's third law of motion? Anyone? Newton's third law of motion. Okay, not to waste time. Newton's third law of motion says that for every action, right, there's an equal but opposite reaction. So action, reaction, action, reaction. For every action, there's an equal but opposite reaction. Right. So let's take this drone for example, right? Now, by the time these blades begin to spin, and there's the way these blades are tilted or the way they are designed, the way they are designed is called an airfoil. They have an airfoil cross section, right? Where we have like a curve. Let me show you here. You have like a curved section at the top here, and you have a flat section at the bottom. So when air flows over, as this thing begins to rotate, air flows over it. Now the air flowing over it flows downwards. That is the action. So as these things begin to spin, the air flows downward. As the air flows downward, which is the action, is an equal and opposite reaction. So that downward flow of air will result in a reaction where a force is generated that lifts this aircraft or this body upwards. Every action, equal and opposite reaction, right? So I don't know if you have played with a balloon before. If you blow a balloon and let's say you put it on a thread and you release the balloon, what happens is that as the air begins to go backwards, the balloon is going to go forwards. That's simply it. For every action, equal and opposite reaction. So as this air now, for example, is being blown downwards, this aircraft is going to go upwards. That's simply put, that's how to explain Newton's third law of motion. Now, another principle, another way to look at it is using Bernoulli's principle. Now, Sir Bernoulli was carrying out an experiment, and then at the end of the experiment, he came up with a principle. The principle states that as the speed of fluid, so whether water or air, let's take air for this instance, as the speed of fluid increases, the internal pressure decreases. So as velocity increases, pressure decreases. Increase in velocity causes a decrease in speed, and then in pressure, and then decrease in speed causes an increase in pressure, right? So as this begins to move, right? As this begins to move, based on how this airfoil is designed, because this place is curved and we have this place is flat, right? The air above your propeller, the air above the propeller, that is the blade, for example, the air above the wings of your aircraft, right, moves faster because this place is curved. It's like you are driving a car and then you are driving downhill. What you notice is that even if you don't press the accelerator, your aircraft begins to accelerate by itself because it is going downhill compared to the one that is going on a straight road, right? So the aircraft accelerates. The air accelerates. So Because this air is accelerating, the pressure above this wing is going to reduce. The pressure applied is going to reduce. So when you now compare this pressure compared to the one below, because the air flowing below has a lower speed compared to the air flowing above, there is more pressure below. So that more pressure below pushes the wing upwards. For this one, for example, now it pushes this blade upwards. Now, because this blade is attached to this drone, and this blade cannot just go alone on its own, the blade carries or lifts this aircraft with it, right? And then that's how lift is generated. And then that brings us to the opposite force, which is weight. Weight is simply the force exerted by gravity on an object, in this case on your drone. That is, it acts downward and it wants to make sure that your aircraft is down. What goes up must surely come down, right? So weight is the force that pushes an object towards the ground, caused by mass times gravity, right? That is the weight. So there is a force that pushes the aircraft down by nature. So for you to generate lift, it means your lifting force, that is the force being generated either through Bernoulli's principle or through Newton's law of motion, has to be higher than the weight of the aircraft for that aircraft to lift off the ground. So imagine a scenario where there is a fire incident in the house. You guys are, let's say, 10 in a room, and then you have a tiny door. Once you have that fire alarm, all of you want to rush out at the same time towards the door. What's going to happen is that because you people are many and all of you are pushing yourself through that door at the same time, your speed is going to be slow, right? All of you won't be able to pass through that door easily or smoothly. But even though your speed is slow, the pressure you are impacting on yourself and also on the door increases, right? But if you guys were to go on a straight line and exit one by one, there's a high chance people will not even touch the door or touch the passageway, and you just pass easily, which means you're moving faster without applying pressure to the door. That's simply how to explain that Bernoulli's principle. And then once you have that, like I said, there's that difference between lower pressure above and higher pressure below, which is pushing upward, will lift off your aircraft. So what you want to do is you have to create a system through which the lifting force is greater than your weight force for you to go up. That brings us to the other forces, which is thrust and drag. So thrust is the forward force which is generated by your aircraft propeller, right, through the air. This thrust must overcome drag to maintain forward motion. So for example, for your airplanes now, you have those big jet engines, right, that are attached to the wing of your aircraft. Those jet engines are what provides thrust. Those are what moves the aircraft forward, right? So the faster they spin, the more your aircraft pulls forward through the air. Now, because your aircraft is in motion, there is a force that opposes motion. We call that force frictional force, right? You see, friction is the force that opposes motion. Good. So that resistance that is caused by friction based on the movement of your aircraft or of your drone through the air is what we call drag, right? So as your aircraft begins to move through the air begins to collide with your aircraft. And as it's colliding with your drone or your aircraft, it tries to slow that aircraft down. So your thrust force is greater than that frictional force for your aircraft to move through the air. How would that make sense? Okay. So let's go to the next thing. Now, your drones actually have the ability to move in 3 axes. And that helps us to provide versatility and maneuverability through the air. So these axes are what we call the 3 axes of flight. So you have your drone, right? And then we have our 3 axes of flight. So the very first one is the lateral axis. Lateral axis is simply an imaginary line. So let's imagine an imaginary line. Very first thing is this. This aircraft now, this drone, as we call it, center of gravity, the CG, right? The CG is where all the weight of the aircraft is concentrated. So let's assume that to be the middle of this drone, right? Good. So now we have an imaginary line. We have lateral axis, longitudinal axis, and vertical axis. So imagine a line that cuts across this aircraft from the right to the left, from the right to the left. So you have a line here that goes through the middle from the right to the left. We call that the lateral axis. Now on this axis, because I have a line like this, my aircraft can go up or down, up or down, up or down, up or down. So imagine that there's a line here, there's a rope here, right? That goes like this. So that makes this drum be able to go up and down around that line, right? Now this movement is what we call pitching. So it's pitching forward, pitching backward, pitching forward, pitching backward. That's lateral axis. Now let's assume another line that goes from the front of this drone to the back of this drone, front to the back. This line here is what we call the longitudinal axis. Longitudinal axis. So across the longitudinal axis, this drone, so you're imagining a line that is here cutting this aircraft into half from front to back, allows this drone to go left and right. We call that rolling. This aircraft can roll to this direction and then roll to this direction, right? And then we have what we call the vertical axis. So imagine a line that runs from the top of this drone to the bottom, from top to bottom, top to bottom. That line allows this drone to move side to side, clockwise or anti-clockwise. So imagine three lines. You have one that cuts across from side to side. So if there's a line that cuts across side to side, right? So imagine a line here. This drone can then go either forward or backwards, right? That's pitching. You have one that goes from forward to back, and then this drone can go this way. Then you have one that goes up to down, and then this drone can go this way. So just imagine you have those three lines, and this aircraft is able to rotate around it. So if I have this line, the aircraft is able to rotate this way, right? This way around this. That's if you tie the rope. If you tie the rope to this thing now, this aircraft will be able to go like this. If you tie the rope this way, this aircraft will be able to go like this. If you tie the rope this way, this aircraft will be able to go like this. Those are the three axes of flight. And that gives us three movements. So you have your pitching, which is forward, backward. You have your rolling, which is rolling left, right. And you have your vertical, turning clockwise, turning counterclockwise. I know it's a lot, but just take it in little by little. Now, this what I just showed you now is pretty much how a multirotor is going to move around this object. Now, your fixed wings, for example, rely on your what we call control surfaces for them to move around this axis. Meanwhile, your multirotors actually controls this movement through what we call differentials, thrust differentials. This is what I will explain in the next. So thrust differential is simply the adjustment of the speed of each of these four motors, right? It adjusts the speed of these motors to determine how it's going to move about those axes. But for your fixed wings, like for your airplane, for example, if you've been in an airplane, you see that there are some surfaces on the aircraft that moves while the aircraft is flying. Like on the wing, something that goes up and goes down. The other wing, something that goes up and goes down. Same at the tail of the aircraft. That's what allows it to determine how it's going to move. But for your multirotors, for example, like this quadcopter that I have here, it has four motors. Speed differential, thrust differential is how we're able to control the drone. All right, so let's talk about drone operations. In this section now, we'll delve into the world of drone operations. How do we actually control or fly this drone? And we'll be sticking with the control of multi-rotor drones, right? Now, all drones generally have four controls for their movement. All drones, they have four controls for their movement. We have throttle, that is THROTTLE, throttle. We have yaw, which is YAW. We have pitch, which is PITCH, and then we have roll, ROLL. Throttle, yaw, pitch, and roll. Now in this section, we'll be looking at how multi-rotor drones are controlled. The reason is because multi-rotor drones are actually the most common drones in the marketplace today, right? And also they are the starting points for many enthusiasts, for farmers, and that's because of their simplicity and their stability. Of course, they come in different sizes and different shapes, right? But their principle is pretty much the same thing. Now, when it comes to your multi-rotor drones, right? Like I said, we have what we call throttle, you have your pitch, you have your yaw, and you have your roll. Your throttle simply controls the speed of all motors simultaneously, thereby determining the altitude. So we have 4 motors here, which is 1, right, 2, 3, 4. When you increase the throttle of your drone, you're increasing the speed of these 4 blades equally, simultaneously at the same time. So if I increase throttle, all these 4 motors are going to increase throttle at the same time. If I decrease my throttle, all these 4 motors are going to decrease speed at the same time. Now, when I increase the throttle, what I'm doing is now I'm controlling the altitude. So I'm saying the drone should go up. Why? Remember, as this thing begins to spin, it spins faster if I increase my throttle. Because it spins faster, more air is deflected downwards using Newton's third law of motion. Because more is deflected downwards, I have more lifting force and my aircraft flies up. So when I increase my throttle now, my drone begins to ascend. When I decrease my throttle, my drone begins to descend. The faster or slower I increase or decrease my throttle is the faster or slower my drone will ascend or descend. You get it? That's throttle. Simple, easy peasy. All the four motors or all the motors rotate equally at the same speed, either increase or decrease. Good. Next one now is your pitch. Your pitch. Now, your pitch control for your motor simply controls the forward movement of your drone or the backward movement of your drone. Now, remember, this is the front of your drone, right? So pitch, you say pitch forward or you say pitch backward. Pitch forward, pitch backward. So even if I turn the drone this way, pitch forward will be the front of the drone, not this side. The front of the drone, and pitch backward will be the back of the drone. How do I control that? When I take my pitch control on my controller and I say pitch forward, what happens is that the speed of these two motors, they decrease equally, right? And the speed of these two motors, they increase equally. So because these two decreases, the lift here is going to be lower. Because these two increases, the lift here is going to be higher. Because it is more, this back is going to come up. Now, because of this, now there's now a reactive force that allows this drone to move forward, right? The reverse happens if I do pitch backwards. So when I say pitch backwards, the speed of my motors in front will increase, the speed of my motors at the back will decrease equally, and then my aircraft will move to the back, right? So the more pitch control I include, determine how fast it's going to move forward or how fast it's going to move back. I hope that's clear. Same thing for my roll. So I can do roll left, roll right. So when I'm rolling right, what do you think is happening? When I'm rolling right, yes, the motors on my right, they decrease in speed, while the motors of the left increase in speed equally, right? And then if I left, the motors on my left, they decrease speed. So this left side is going to lower. And then the motors on my right, they increase the speed increases, and then my drone goes to the side, right? So I hope you are following. That's pretty much how it works. That brings us to the next one, which is yaw. Yaw is simply the movement of my drone clockwise and counterclockwise. But how does this work? The first thing you need to note is that these 4 blades don't rotate in the same direction. These 4 blades do not rotate in the same direction, right? So I have 4 blades. Let me use my screen to explain. So I believe you can see my pointer, all right? So if you look at this diagram here, for example, this motor here, this one here, this particular one here, you can see this arrow is showing you how this blade rotates. So this blade actually rotates towards the left. That is, it rotates counterclockwise. This blade rotates clockwise. This blade at the back here rotates counterclockwise. This blade at the back here rotates clockwise, right? So if you see it, so we have this blade number one. If you look at this picture, here. Look at this blade now. This blade rotates counterclockwise. This blade rotates clockwise. This blade rotates counterclockwise. This blade rotates clockwise. So basically, I have 2 blades that are adjacent to each other that rotates clockwise, and I have 2 blades that rotate counterclockwise. So all opposite blades rotate in different direction. So if I count one is clockwise, two counterclockwise, three clockwise, four counterclockwise, like that, right? That allows for stability, and I will explain why. So for example, let's assume that all these blades were rotating in equal direction. If all these blades were rotating clockwise, what is going to happen is that since all the blades rotate clockwise, my drone is going to rotate counterclockwise all by itself. So the drone is not going to be stable. Remember, we said for every action, there's an equal but opposite reaction, which is third law of motion, right? Good. So if all these blades were rotating clockwise, the reaction will be that this body wants to rotate in the opposite direction equally at the same speed as these blades are rotating. So what I'm going to have is I'm going to be having a spin out. I don't know if you have watched action movies before, where helicopters are flying. Maybe an helicopter is flying maybe for a military purpose or for all these action movies now. And then you see that the helicopters actually have a tail rotor. And in movies, if they don't shoot the main rotor, you see that they always target the tail rotors. If I've watched movies before where they shoot down the tail rotors, what you notice is that helicopter, once they shoot that tail rotor, begins to spin till it lands to the ground and crashes. The reason is because for your multi-rotor now, for example, you have multiple rotors, right? And that are rotating clockwise and counterclockwise, which means they're countering themselves. That's what allows you to become stable. Your helicopter only has one major blade, right? That big rotor blade in front. And that thing can only rotate in one direction. So let's say it rotates clockwise. To counter it, they needed a tail to provide a counter force so that the body of the helicopter does not keep spinning in the other direction. So once you take away that tail, right, the helicopter will begin to spin in the opposite direction. And because that is not stable, it's going to crash. The motorators are easy because now you have two motors rotating clockwise and then you have two rotating counterclockwise. So when I'm applying throttle, for example, which allows the drone to go up or come down, I have two blades that are rotating clockwise. So let's assume I put them at 50%. So these two blades are rotating clockwise at 50% speed. These two blades are rotating counterclockwise at 50% speed. Because this clockwise blade is rotating clockwise, right? This drone will want to rotate anti-clockwise. But then I now have two other blades that are rotating anti-clockwise that want this drone to rotate clockwise. So this is saying rotate clockwise 50. This is saying rotate anti-clockwise 50. 50 minus 50 equals to 0. So your drone will stay on a spot, right, but increase speed and decrease speed. Are you getting it? These two fronts now, this one is rotating clockwise, this one is rotating anti-clockwise. This one is rotating clockwise, this one is rotating anti-clockwise, right? So when I reduce the speed of these two, I'm reducing the speed of a clockwise blade and an anti-clockwise blade. I'm increasing the speed of a clockwise blade and an anti-clockwise blade equally. That's what allows this drone to stay straight and just go front. That's allows this drone to stay straight and just go back. I'm increasing speed and decreasing speed of, I'm decreasing the speed of a clockwise and anti-clockwise blade like this. Increasing the speed of a clockwise and anti-clockwise blade like this equally. That allows this drone to stay straight and just go like this or go like this. Now, for me to yaw, which is to turn, what I'm doing is I'm increasing the speed of the clockwise blade and reducing the speed of the anti-clockwise blade, right? So if I increase the speed of my clockwise blade, I've increased the reaction, which is anti-clockwise reaction. So if I increase the speed of my clockwise blade, my drone is going to turn the other way anti-clockwise. You get it now? This drone is now going to turn this way. Now, if I increase the speed of the clockwise blades, of the anti-clockwise blades, if I increase the speed now of the anti-clockwise blades, it means I'm increasing the clockwise reaction. So my drone is going to rotate clockwise. The difference in speed of the clockwise blade and the anti-clockwise blade will determine how fast my drone is going to spin clockwise or anti-clockwise. And then if I want it to be stable again, all the speeds of the motors will rotate equally. How would that make sense? Now the thing is, if you are to do this and control this by yourself with your hand to fly it, you have a lot of issues. And that's why there's a flight controller. So the flight controller receives your command, and based on your command, it determines which motors it needs to increase the speed of or decrease the speed of. And then it sends that signal to this drone, and then this drone to these motors, and then these motors do it by themselves. So it's pretty much automatic. So you send a command. Based on that command, the flight controller will say, okay, increase speed of clockwise blades 75%, decrease speed of anti-clockwise blade by 25%. Okay, good. And then the drone will act in that direction. That's pretty much the principle behind the operation. Okay, I hope that makes sense. So for example, now for you to control this, right, make use of a radio transmitter to control these operations. Now we have different kinds of transmitters. So we have like 5 channels. You have channels for your transmitter. So remember I said we have 4 controls on your drone. You have throttle, you have pitch, you have yaw, and you have roll. That gives us 4 channels, right?
Hello, Mr. David. I don't know if you can hear me. We can't hear you again, so it's hanging. Your video is hanging, so I don't know. It can be a result of network. So if you can hear me, probably you try and give a recap of that part. Hello everyone. We're having issues with network. I really don't know, and it's up to me. It's not raining, so we don't have any power against over that. So kindly give us few minutes to fix this, and we'll be right back. Thank you. Hello everyone. So I'm trying to get in touch with Mr. David. So hopefully you'll be able to join us back soon. So really having issues with network. So I'm still trying to connect with him now so he can join back. Just give us a few minutes. Thank you. Okay, now. Hello. I believe you can hear me
Hello?
now. Thank you. Okay. So yeah, I think you are almost done. So
You lost me. Can you specify where the stream ended?
yes, yes. The slide you have to upload the slide again because I don't have access to it yet.
Okay, stand by.
And
Stand by. Yeah.
apologies everyone. So we trying to round up. Okay. Uh, so you have to move. We've talked about all of this, I guess. Yes, yes. This section.
I'll see you. Right. Okay. 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 So when you lost me, I already spoken about throttle and yaw, right? Or where was I?
Yes, yes, yes. You've spoken about throttle and yaw. Is this slide specifically that I noticed that you went up?
All right. All right. So I'll just give you a rundown again, and then I'll continue.
Okay. Sorry for
All right.
apologies. Okay, thank you.
No problem. No
Um,
problem. All right. Can you hear me?
yes, yes. I can hear you very well, loud and clear.
Okay. Good. So like I was saying, right? Your drones pretty much work on speed differentials, right? So like I said, we have four motors, and I said we reduce or increase the speed of these motors to determine how we move. So for your pitch, for example, to pitch forward, by decreasing the speed of these two forward motors and increasing the speed of these two backward motors. If I increase the speed, I'm increasing my lift. So the back is going to raise up because it has more lift. This front has less lift, so it's going to go down. And then the reactive force will push this aircraft, this drone forward. The opposite happens for me to move back. Now, for me to go to the left or to the right, for me to go to the left now, for example, now, which is to roll to the left, the speed of these left motors decrease. So I go in this direction, and then the opposite happens here, right? So these motors now that raise up, the speed increases compared to this motor, and then it causes this drone to move this way. That's how you roll. For throttle, like I said, the four motors spin equal speeds, right? Equal speeds. So if I increase the speed of the four motors simultaneously and equally, the drone goes up. If I decrease the speed of the four motors equally and simultaneously, the drone goes down. That brings us to your movement, right? Now, I said for your, to explain your, you need to note that these four blades, these four motors do not rotate in the same direction. And I'm going to use this image here on my screen to explain. You can see my laser pointer. So I have four motors here, and you will see that the ones labeled 1 and 3, the motors are rotating clockwise, while 2 and 4, the blades are rotating anti-clockwise. The reason for this is because, like I said, for every action, using Newton's law of motion, for every action, there's an equal but opposite reaction. If all these blades were to rotate in the same direction, let's say clockwise, the reaction will be an anti-clockwise reaction. So this drone will rotate, this drone will rotate in the opposite direction. So if these motors are rotating clockwise, the drone will rotate what? Anti-clockwise. If all the blades were rotating anti-clockwise, the drone itself will start rotating clockwise. That will cause imbalance and you'll not be able to control the drone, right? And that's why we have two blades rotating clockwise, two blades rotating anti-clockwise. And if you look at them, they are opposite each other. That is to create balance. So for you to yaw, what is happening is you are increasing and decreasing the speed of the clockwise motors or the anti-clockwise motors. So if I increase the speed of my motors that are rotating clockwise, which is the action, I have an anti-clockwise reaction. The anti-clockwise reaction means my drone will rotate anti-clockwise. If I increase the speed of my anti-clockwise blades, I will have a clockwise reaction. A clockwise reaction will cause my drone to rotate clockwise. I believe that makes sense. So the more the difference between those speeds is the faster my drone is going to rotate in either direction, right? So if the difference is small, my drone will begin to rotate clockwise slowly, or anti-clockwise slowly. The difference is much, my drone will begin to spin. Just like you see in helicopter movies, right? Because your helicopter just has one big blade and not multiple blades. That blade only rotates in one direction. And that's why your helicopter has a tail rotor to counter that reaction, right? If you have watched movies before where you see that they shoot the helicopter down, they shoot the tail of the helicopter, you notice that the helicopter begins to spin abruptly till it lands and crash because what? It is not stable. That's pretty much how it operates. And for us to control this, it's very difficult for you to control the speed of all these four motors manually. And that's why we have a flight controller inside the drone. And then to control this, you have your controller, which is your transmitter, right? Something like this. Now, this your transmitter sends signal to your flight controller. Your flight controller interprets that signal and then sends the necessary command to your motors all by itself. So you don't have to worry about which motor is spinning in which direction. The flight controller does that and handles that by itself, provided your blades are put on your drone correctly. Now that brings us to our transmitter. Now, we already said we have four major controls for your drone. You have your throttle, your pitch, your roll, and your yaw. Each of these controls are assigned independent channels, right? Each of them are assigned independent channels. So, for example, I have this controller with me. This movement up and down is one channel. This movement left and right, another channel. This movement up and down, a channel. This movement left and right, another channel. That's four channels. Now, depending the way this each of these channels now, they are assigned to each of these four commands. So I can have my throttle here, up and down. I can have my yaw here, left and right. My pitch here, up and down. My roll here, left and right. This configuration I just explained now is called a mode 2 setup or a mode 2 configuration. Or we have other modes. We have mode 1, we have mode 1, we have mode 2, we have mode 3, we have mode 4. Not to complicate anything, we'll just stick with mode 2, right? So mode 2 simply put, you have your throttle, you have your yaw, you have your pitch, and you have your roll. So when I take my throttle stick and I go upward, I'm simply telling this drone to ascend. And when I go downward, I'm telling this drone to descend. If I take this stick and I take it to my right, I'm telling this drone to rotate clockwise. Take it to my left, then this drone to rotate anti-clockwise. If I take this other stick, which is my pitch control, and I say up, I'm saying this drone should pitch forward. If I say back, I'm saying this drone should move backwards. If I say move it right, I'm saying this drone should go to the right. If I'm going left, I'm saying this drone should go to the left. That's pretty much it. Now your transmitter can come with more than 4 channels. So we have like 5 channels, 6 channels, 7 channels, 8 channels, 16 channels transmitters. Simply put, all these extra channels simply allows you to carry out extra functions. For example, controlling your camera, snapping pictures, turning on and offing a light. You have an auxiliary light. If you have a spray tank, powering on your sprayer, turning off your sprayer, among many other things, right? But practically for your drone controls, you have just 4 major channels. And then
David, you are up again. Hello, Mr. David, you are up again. I don't know, it's your network or something. So, Sorry everyone. Mr. David is currently off again. The network has been really crazy. Let me try and see where to bring him. So we can just entertain question and answer, then we wrap it up. Okay, welcome back, Mr. David. So I think we've had enough time. So I quickly just want us to entertain question and answer. So if you have any from our participants, so if you have any question here, you have moved past this slide. All right. Someone was saying you have moved past this slide. Okay. That was, I think we have network issues. We really have network issues. I don't like it. Well, Mr. David, if you can hear me, so I think we can entertain question and answer for anyone who has any question to ask in relation to the slide or the teaching.
Yes, I can hear you. Can you hear me?
Yes, yes, yes. I can hear you. I can hear you.
Yes, you can
So
entertain questions. That's fine. Any question? Kindly ask questions if you have any. Just have any questions on YouTube? No questions?
I'm trying to. Okay, okay. Let's just give 2 minutes. I think some people are actually typing in their questions. So
All right.
all right, Mr. David, thank you so much for joining us. Thanks so much for honoring our invitation. We are sincerely grateful and we are expressing our unreserved appreciation for you joining us again in this course. So we only give, I'm going to be giving 2 minutes, yes, for anyone who has questions. You can drop in your questions So in the absence of question, that means we've come to the end of this presentation. Thank you so much for that wonderful teaching. Although we had issues with network, internet along the line, there are lots of technical errors, but all glory to God, we are here. So if you have questions, drop your questions. So in the absence of questions in 2 minutes, that means we are going to call it a wrap. Uh,
Hope they are not cooking questions for me like this.
okay, okay. Yeah, hello everyone. Just send in your simple questions straight from your mind. Because our speaker is like, are you setting wire connect with questions?
Ah,
Class.
they
Yes,
are
yes,
setting IELT and SAT questions for me like this.
yes. Okay. In the absence of questions. Okay. This question actually popped to my mind, so let me ask it from my own end. Yeah.
Okay.
Like ornithopters, can they be classified or categorized under drones as well, or how can we? Or is ornithopter just an aircraft? I really don't know. I know they flap. They use flappy wing operation or principles for flight, or can they be categorized under drone as well?
Well, I wouldn't say categorically, I would say no. And that's because of quite a number of reasons. So, number one, right? Of course, the technology is improving, right? We now have ornithopters that are able to, fly, and then they have like a camera, and then they are used for, let's say, surveillance and security. But like when you look at the technology is not yet advanced to the point where we can pretty much say, okay, this is now a system that can be used like large scale or extensively. So it's too much in the,
Okay.
let me say, let's say it's in the experimental stage, right? And then when you compare an helicopter to your regular quadcopter and other kinds of drones, it's not as efficient as those kind of things. So we won't necessarily call it a drone, because if I'm a farmer now, for example, there's nothing which I want to use on the copter. So right. So of course, like I said, it depends on one of the major things that what's used to classify drones are number one is the payload. That is what problem can I
Okay.
use this to solve, right? So as someone who's in the commercial, or let's say in the civil world now, we're looking at surveillance, we're looking at um, mapping, we're looking at all these high-end enterprise use cases. An
Yes.
helicopter will not necessarily give me that because it's not efficient for those kind of activities. Of course, let's assume if I was in the military now, right, I could have an helicopter. I know that, okay, this helicopter pretty much is a system that I'm using for surveillance, and it is hard to detect, right? So in the military space, it could be categorized as a drone, provided it has an autonomous system, and then it is used for carrying out some major activities, right? But on the grand scheme of things, I would say no, at least not yet.
Okay, okay, okay. All right, thank you so much. Thank you very much, Mr. David. So, I think we don't have questions. So, in the absence of questions, that means we finally come to the end of this presentation. Thank you so much for your time. Thank you, thank you. We are so much grateful for you joining us, and we hope that in the near future have other presentations or engagements like this, you will love to always join us to share your thoughts as an expert in the field of drone industry. Thank you so
Expert,
much,
expert.
Mr. David.
Always a pleasure. Thanks for having me once again.
All right, all right. Thank you. Bye. Uh,
Bye bye.
okay. Thank you. All right, thank you everyone. We've come to the end of this presentation. Since we do not have much question and answer, So tomorrow we are going to be having the flying farmer himself, uh, who is the vision lead for Precision Field Academy. That means we are hearing from the horse's mouth tomorrow. So he's going to be sharing his expertise in the aspect of drone technology in crop protection, and yeah, just going to be sharing his view directly to us as a precision agriculture specialist, leveraging drone technology. So I'm going to communicate that to the main WhatsApp group so we can have that information before tomorrow. All right, thank you, everyone. See you tomorrow for another insightful section. Thank you. Bye.